Alright, so limiting reactants. So for the last few days we've been talking about stoichiometry, okay? And remember, on our notes, we discussed how stoichiometry is the study of quantitative relationships between the amounts of reactants used and the amounts of products that will be formed in a chemical reaction. So that in mind, we've been calculating the theoretical yield, or the maximum amount of product that can be produced from a given amount of a reactant, okay? And so with this, for us to find our theoretical yield, we also have to keep in mind limiting reactants. So a limiting reactant is the reactant that is consumed first. It is limiting us from producing more of the product. So let's look at this in terms of something real world that we can work with. So you're trying to make hamburgers for your family, and you only have 3 hamburger patties, 4 sets of buns, 6 pieces of cheese, and 7 tomato slices. So let's say that one cheeseburger is 1 piece of cheese, 1 set of buns, 1 hamburger patty, and 2 slices of tomatoes. So we have to figure out how many hamburgers or cheeseburgers we can make for the family. So we can see here that we can only make 3 of the hamburgers based off of the combinations, okay? And that's because we are going to have 1, 1, 1, and then 2 of these right here. And so that makes 1 hamburger right here. Okay, so I've used this up, I've used this, and this one up. All right, then I am going to do a second hamburger where I have 1 hamburger patty, 1 set of buns, 1 piece of cheese, and then 2 slices. Okay, so let's see if we can make a third. 1 hamburger patty, 1 bun, 1 piece of cheese, and then 2 slices. So that's 3. Well, notice I cannot go on and make 4 because there's not another hamburger patty here. So that means I can only make those 3 hamburgers or cheeseburgers, and then I'm going to have 1 bun, 3 pieces of cheese, and 1 slice of tomato left over. Okay, so we would consider our hamburger patties our limiting reactant, and anything left over is what we would call excess, which I'll explain later. Alright, so what we're going to do is we are going to calculate the limiting reactant by using stoichiometry to calculate the potential amount of products that can form or that can be produced, and then whichever reactant produces the least amount of product limits the overall reaction. Okay, so what we're going to do is we are going to look at a couple of these problems here on our unit sheet, and we are going to build off of it. Okay, so with limiting reactants, you are going to get 2 starting amounts and not just 1 like your regular stoichiometry problems, but it's nothing new. The first thing we are going to do is we are going to balance a chemical equation. So it says that nitrogen reacts with hydrogen gas and we end up producing ammonia. So let's write that down for me. Okay, this right here. Alright, so limiting reactants. Number 1. Let's see if I can get rid of this glare right here. Let's add that light back. Refocus. Alright, so I have nitrogen gas, and it's reacting with hydrogen gas to produce ammonia. So now we have to balance it. We're going to put a 2 here to fix nitrogen, because we have 2 on the left, and then I'm going to put a 3 here, so I have a total of 6 hydrogens on the reactant side as well. If you are still struggling with balancing equations, definitely go check out my balancing equation video to help you out and refresh what you need for the beginning of a stoichiometry problem. But so I'm going to continue putting what I have underneath the chemical reaction equation, so that way we don't have to keep on reading the problem over and over again. So it says I have 3.45 moles of nitrogen and 4.85 moles of hydrogen. So let's put that underneath here. Alright, so the whole point of a limiting reactant is to see how it is limited, or how it limits, the amount of product that is produced. So what we are going to do is we are going to convert each of these starting amounts to a product. And so for this one it's easy because we know we only have one product to convert to. But for any other problems, you always want to look to see what the problem is asking and convert to that product. So it says, what is the limiting reactant? So that's what we're going to do first. And then we are going to see how many moles of ammonia NH3 will form. So we're working towards NH3. So I'm going to put a question mark under here, and it wants it in moles. And so then that way we can do our first problem finding the limiting reactant and then find our NH3 value. So what we're going to do is we're going to see how much ammonia we can produce if we are working with 3.45 moles of nitrogen gas. And so you guys know how to convert from one substituent to another. I'm going to convert to moles first if necessary, and it's already in moles, so I don't have to convert. I'm going to now use my mole ratio to convert from what I started with to my desired substituent, or to my desired compound, which is NH3. So I see that I have a 1 in front of nitrogen and a 2 in front of ammonia. So then I convert to my desired unit. Well, it wants my answer in moles, so I'm already at moles. I don't have to go any further. I can go ahead and plug this into my calculator. And when we plug this into our calculator, we are left with 6.90 moles of NH3, right? So that's how much that can produce. Well, that can't tell me if this is a limiting reactant if I have nothing to compare it to. So what I want to do is I want to also take 4.85 moles of H2 and see how much ammonia this can form. So I know I have 2 moles of ammonia, or NH3, and 3 moles of hydrogen gas. And of course our moles cancel out. And so in total, 3.23 moles of NH3 can form. So now we just compare. All right, I can either have 6.90 moles form or 3.23 moles formed. So we're looking at what's limiting us, or what is going to be used up first and causes us to have a smaller amount of product. So notice, if I have 4.85 moles of hydrogen, I only can produce 3.23 moles of NH3. So really, whichever is the smaller number will tell you what is limiting. So because I only can produce 3.23 moles of NH3 with 4.85 moles of hydrogen, hydrogen would be considered my limiting reactant, and I always write my statement, H2 is LR, or my limiting reactant. Okay, and so by doing it this way, we also answer our second question. How many moles of ammonia will form? Well, since this is my limiting reactant right here, I know its answer is the only amount of ammonia that can actually form. Okay, so there are 2 different ways to do this. You can do it this way, or you can only use one step and then compare reactants. So I would do convert moles of nitrogen to moles of hydrogen and then compare what I need to what I have. But that other way is very complex, and so I normally don't show that. But if for some reason this method does not work for you, then you can get with me individually and we can talk about the other method that is used. That being said, the only way to get great at these problems is practice. So let's continue looking at our unit sheet. All right. Number 2 on our unit sheet says a welder has 20 moles of acetylene gas and 10 moles of oxygen gas. So that's what's reacting together. So let's go ahead and build our formula, or our equation, for number 2. I have my acetylene gas reacting with hydrogen, or not hydrogen, sorry, oxygen gas, and it's going to produce CO2 and H2O, and we should know that by now because this is combustion. When oxygen is added to a hydrocarbon, we always get carbon dioxide and H2O. So our first step in stoichiometry is always to balance the equation. So I put a 2 here, okay, and that fixes carbon. Well, I have hydrogen fixed already. Well, notice I have 4 oxygens here and 1 oxygen here, so that's a total of 5. And so that's very awkward. So we can either multiply 2 by 2.5 to get 5 and then double everything, or we can use the technique of doubling everything already, and then that usually will be easier and fix our oxygen issue. So I have 4 times 2 is 8, plus 2 more is going to be 10. So I'm going to simply put a 5 right here, and it has everything balanced out. All right, if that was too quick of balancing for you, make sure you draw your inventory chart and then count up all of your atoms again. Right, now that we have it balanced, I'm going to add my numbers that the problem has. I have 20 moles of acetylene gas, and I only have 10 moles of oxygen. Okay, and so what I'm going to do is I'm going to convert both of these to a product to find out which one is my limiting reactant. So let's see which one or which product it asks for. It says identify the limiting reactant, which we're fixing to do, and then it asks you how many moles of carbon dioxide gas. So it'll be a good idea to go ahead and work towards carbon dioxide gas, since that's the second thing it asks for. So I'm going to take my first reactant, which is my acetylene gas, and I am going to convert it to my product and see how much of CO2 it can actually form. So I use my mole ratio, 4 moles of CO2 for every 2 moles of C2H2. And when I do that, I get 40 moles of CO2. And then I'm going to do the same thing for my other reactant. I have 10 moles of oxygen, and I want to see how much CO2 will be produced with this amount. So I use my mole ratio, 4 moles of CO2 for every 5 moles of O2. And so oxygen, if I was given 10 moles, can produce 8.00 moles of CO2. So notice, oxygen is stopping me from forming a full 40 moles. So oxygen is considered our limiting reactant. And because it's our limiting reactant, only 8 moles of CO2 can be created or will form. And so this answers both my questions. What is the limiting reactant, which was oxygen, and carbon dioxide, I only can form 8 moles because of my limiting reactant. Okay, so hopefully this is not too bad, but let's look at one that's giving you a mass and not just moles. Okay, so for number 4, we have 100 grams of sodium sulfate, which reacts with 50 grams of barium nitrate. How many grams of barium sulfate will form? So the first thing we're going to do for number 4 is form the equation. I have sodium sulfate reacting with barium nitrate, and then it's a double replacement, so sodium is now paired with NO3, and barium is now paired with SO4. So I got to balance it. I'm going to put a 2 right here, and this will fix my 2 sodiums and 2 nitrates, so it's fully balanced. And now I'm going to place the numbers they gave me. I have 100 grams of sodium sulfate, and I have 50 grams of barium nitrate. So we are going to convert these both to a product to see which one will make less of that product. So the problem asks us how many grams of barium sulfate will form. So we are working towards barium sulfate, and so we are going to see which one is limiting, and then how much barium sulfate it can create will be our answer. So I have 100 grams of sodium sulfate, and I am trying to get all the way to barium sulfate, so I have to use stoichiometry. I know that I have to convert to moles if necessary, and it's necessary here because I started with grams. So I'm going to put 1 mole of sodium sulfate at the top, and then I'm going to add up sodium sulfate's mass. You plug it in the calculator, you get 142.05 grams of sodium sulfate. Okay, so grams are going to cancel out. Now I'm going to use the mole ratio to go to my desired substituent, which is barium sulfate. That has a mole ratio of 1, and then I'm going to cancel out moles of sodium sulfate. And then next I'm going to my desired unit. Well, it does ask for barium sulfate in grams, so I'm going to put 1 mole of barium sulfate. Then I'm going to add up this formula mass. And so when I plug that in my calculator, I get 233.40 grams of barium sulfate. All right, moles cancel out, and I plug this in my calculator, and I get 164 grams of barium sulfate. Let me just make sure I use the correct amount of sig figs. Right, I had 3 sig figs, so I'm going to carry this. It should be 164.3 grams. Okay? And then now I'm going to do my second reactant here. I have 50 grams of barium nitrate. Okay. And I'm going to convert to moles if necessary, and it is because I started in grams. Right, I add up barium nitrate's mass, and I get 261.35 grams. And grams are going to cancel out. Now I use my mole ratio to convert from what I started with to what I want, which is my product barium sulfate. And then lastly, I go to the unit that is desired, which is grams here, and I get rid of moles of barium sulfate by putting 1 down here. Add up barium sulfate, or you've already added up barium sulfate, and it's 233.40, and we plug this in our calculator. And when you do that, you get 44.7 grams of barium sulfate. So now we see which one is limiting. Okay, well, with 100 grams of sodium sulfate, I have 164.3 grams of barium sulfate. But when I have 50 grams of barium nitrate, I only can produce 44.7 grams. So that means that barium nitrate is limiting, which means I will only be able to produce 44.7 grams of barium sulfate. Alright, so that is basically the explanation for limiting reactants. Okay, you can find which particular compound or which reactant is limiting and then solve for one of the products. And so go ahead and practice 3, 5, and 6, and then I will post the answers on Google Classroom for you to check.